All right, transformation of functions is the next topic. Transformation of functions. So when we do transformations on functions, it means they move somewhere from where they normally move. So some families of graphs, on this page is a typical quadratic, a parabola. So some families of graphs have the same basic shape. For example, the graph of y equals x squared with the graphs of 4 other quadratics are shown in this figure here. And so what you have is, you'll see when we add 2 to the quadratic, that has an effect of shifting it up. Or if we were to subtract 2, it would take x squared and it would shift it in the downward direction. So these are vertical shifts, upward or downward. Horizontal shifts, you'll see that the x squared property is what creates the parabola shape. And so we're going to take the quantity x plus 2, and when we put that quantity in parentheses and then square it, that has an effect of shifting the basic graph to the left or right. And so you'll see when we have a plus in here, that actually moves it in the negative direction, because it shifts everything back to, it's like starting 2 earlier. So instead of starting at 0, we get 0 when x is negative 2. And so it shifts it to the left. If I subtract 2, that's going to shift it to the right. So that's the second type, is a horizontal shift. A third type is called a reflection, and we get a reflection simply by putting the opposite or minus sign in front of x squared. So instead of x squared, which opens up, we put minus x squared, which opens down. And then you'll see here's one that does all 3. So instead of just y equals x squared, we have x plus 3. So the x plus 3, that's going to shift it 3 units to the left, and that's inside the parentheses. And then it's a minus that part squared, so we're going to flip it over from what it normally is. And then it's 1 minus that, which is really like adding or having a positive 1 out in front. And so that's going to have effect of taking that and moving it up 1. So we can use these transformations in combination to get different results. And you can do this with any amount of different types of graphs. So each of those graphs is called a transformation. Transformation just means movement or shifting, reflecting, sliding, all those things. So we talk about vertical shifts, horizontal shifts, and reflection. So sometimes we use the word slide, right here, real sloppy for you guys, slide for vertical and horizontal shifts. And then we also sometimes include rotations in reflections. You guys don't have to worry about that right now, but we'll talk about that maybe at different points. But reflections are a flip. So I'll write flip here for reflections. So flips, slides, reflections, shifts, they all are saying the same kind of thing. Function notation lends itself well to describing transformations in the graphs on the plane. And so, for instance, here's some different categories again. When I take the function and add or subtract a number, that results in a vertical shift, up and down, vertical. F of x plus 2, you see I add 2 inside the quantity. That has that effect of shifting it to the left, beginning it earlier. Or if I was to change this to minus 2, that would have the effect of shifting it to the right. When I make it opposite of the function, that's a reflection. So instead of opening up, it's going to open down, or it's going to do the opposite thing. It's going to reflect. And then we can combine them in different ways. So this one would be, I would take my basic transformation and I would shift it 3 units to the left, and then this plus 1 is going to let me know that it's going to be up 1, and it's also going to be reflected because I have this minus sign. So you can use them in combination again. So the following page is kind of a summary table. This is in your textbook as well. Here's the original graph is y equals f of x. Subtracting a constant shifts the graph c units to the right. Adding a constant shifts it c units to the left. Just subtracting a constant. So these are, you'll notice again, are inside the parentheses. And these are outside, so that's how you know whether it's a vertical or a horizontal shift. So minus c is going to shift it down, plus a number is going to shift it up. And then if we go opposite of the whole function, that's going to reflect it about the x-axis. If I take f of negative x, that's going to reflect it about the y-axis. And then reflection about the origin, I'm going to combine both of these two into one statement. And so I have negative f of negative x. So we see we replace both x and really our y value with negatives.